Hello people, so no intro today as I found out based on my analytics that I'm really bad at intros. So what we're gonna do today? Today, after all the talks that I've seen and heard on CT scanning, we're gonna take a look, as the title says, as the thumbnail says, at the math of CT scanning. We're gonna try to answer using math. If you're new to the channel, first of all, welcome. I'm Barrett, I'm a mathematician. We're gonna try to address the question, can you profit from CT scanning? So I've seen a few videos about it. I've seen one the other day where I heard a lot of nonsense, and today we're using math. So what we're going to do is we're going to try to build a model, make some hypothesis. I'm going to talk you through it. I'm going to show you some math, which is really simple math. If you graduated high school, you should be more than able to understand it, but no worries, I'll go easy with that. I will try to be as explicative as possible. And at the end of it, we're going to try to see if what we analytically derived makes sense. So we're going to try to take a look at some numbers and see if the conclusions we came up with actually make sense. Now, there could be some mistakes. I double checked, everything should be correct. But if you find any mistakes and you want to point them out in the comments down below, let me know. As well as you want to join the Discord and you want to let me know if there's any mistake, you find any mistakes in the process, let me know. So without wasting too much time, we're going to start with hypothesis. Now, the way I solve problems, and most mathematicians do, is first of all, you need to identify what the problem is. You need a question. Once you have a question, you can start to make some hypotheses. Now, I do have some notes here. So if you watch me reading, it's basically me reading the notes. As well as I'm going to share my screen in just a second, and you will be able to see my writing so we can work this out together. And I will try to be as quick and explicative as possible so everything is clear and there's no room left for doubt. Now, the first hypothesis is it's going to be on what product we're going to scan. Now, we can scan both boxes and packs. The model applies to both. There's going to be just a few different things you're going to have to do when considering boxes or packs. Now, the first question we need to address for can we profit scanning boxes, when is it worth to scan a booster box or a pack? Now, I'm going to use box and pack throughout the video. You can change box with pack and pack for box are going to be the same. So you can just call it sealed product. You might hear me say box or pack. It's no matter what, we're going to consider both for the model as they apply for both. So with some thinking done, you could argue it makes sense to scan a box if there is a card within that box, within that sealed product, whose value is higher. So the market price of that card is higher than the market price of the item. Let me show you an example. Rayquaza Gold Star, if I'm not mistaken, in raw near mint condition, is valued higher than a loose pack of EX Deoxys. That's a possibility where it makes sense to scan a box. Now, let me give you another example. Temporal Forces. If I'm not mistaken, the most expensive card in the set is the Raging Bald at around $80. If the box costs $90, you can already tell that it's not going to make sense, right? If you want to find a card and by finding it, let's say you find the Raging Bald in one of the boxes you scan, right? No matter what the price of scanning is, we're going to go over that. But if the box costs 90 and the card within the box costs 80, and to get that card, you're going to have to open the box. So you're going to lose 90 to make 80, you're losing $10, right? So that doesn't make sense. So the assumption number one is the market price of the sealed item must be greater than the market price of the card you're looking to get, the chase card. We're going to call it chase card. Now, at this point, we are in a situation where the chase card is worth more than the sealed product. And at this point, you could be wondering, okay, but when does it make sense mathematically? Where can I profit? When does it make sense for me to actually scan the product and have a profit? And that's what this video is all about. We're going to try to find an answer, and we will. Trust me, we will. And we're not gonna use you're not gonna use examples. We're not gonna cherry pick. I'm not gonna show you some stats here and there. we're going to derive a mathematical model with the assumption we're going to make right now, which are very realistic, and we're going to see when it makes sense to actually scan the item. Okay, so at this point we can start to get into the math. And let's call some variables, right? Let's give some names so we can start to derive the mathematical model, and I will try to talk you through it. So let's call P what? P is the probability of finding the chase card out of one pack. Once again, pack or box, we're going to go over it towards the end of the video, and I'll show you how it doesn't matter the assumption you make, as long as you stay consistent, that you can change between a pack or a box. It doesn't really matter. Now, the other thing we're going to consider is, let's call it C of P, cost or else market price of a pack. Now, another thing we're going to need is CS, the cost of scanning, right? And one thing I heard in one of the videos, even if scanning is free, you're not going to make money. Well, that is really false, and we're going to prove it in just a second. So another thing we're going to need is, let's call it C of C, the cost or else the market price, one should say, of the chase card, right? Because we're interested in that are some variables that we are going to use. Now, at this point, we can already start to construct our model. Now, the question is basically, let's say we want, the whole thing is, we want to send the pack, we're going to consider a pack, we're going to send a pack and see if it makes sense to actually send it, get it scanned, and can we make money off of it. Now, the moment you have a pack or a box, whatever, or on scan, we're going to consider the pack, you're basically holding in your hands this quantity right here. You're holding the cost, the market price of the pack. Now, the moment you send it off to scan it, then that's what you're holding, right? The cost of the pack minus the cost of scanning. That's when you send out the box. Now, the good thing about scanning is that they don't need to open the box, right? So you can get the box back and actually sell it at the pretty much market price, right? You can assume that the market price hasn't really changed within the time span you send the box and you got it back. I think you can make that fair assumption. So even if you don't find the chase card in the box, in the pack, you can still get it back and the market price is going to be unchanged. What you lost basically is going to be this quantity right here, the cost of scanning. And however, when does that happen? That happens when you don't find the chase card. So when mathematically you don't find the chase card? Well, you don't find it with probability 1 minus P. Remember, because P is the probability of you finding the chase card out of the pack. So this quantity right here is going to represent the moment when you send the box, the pack, you get it back, and there's no chase card. So you're left with this quantity. This quantity is in US dollars. If you want to put it a measured unit, it's US dollar. It's a price, right? And however, you may also find the chase card, right? And that happens when you find the chase card, what are you left with? Well, if you find the chase card, you're going to have to open the box, right? And when you open the box, basically, you no longer have the price of the box, the market price of the box, but you have the price of the chase card minus the cost of scanning, right? And when does that happen? Well, you're going to do that. You're going to open the box only when there is the chase card. When will you find the chase card in your box? Well, that happens with probability P, as we define above here, right? P. So that is your expected value of scanning the box, right? I hope that was clear. So when you scan the box, that's what you're left with. You're going to be left with the cost of the pack minus the cost of scanning with probability 1 minus P. So basically the chances of you not finding the chase card, and then with probability P, you're going to be left with what? With the value of the chase card minus the cost of scanning. Now, at this point, the question is, when do I profit? Well, that's your expected value, right? And you only profit when that expected value, so it's going to be your revenue, is greater than the cost. What is the cost? The cost is the cost of the pack or box, once again we're going to consider a pack, plus the cost of scanning. That is your expenses. So when EV is greater, this symbol right here stands for greater than what? Than your cost. So this is going to be your revenue, if I'm not mistaken. That's how you call it. And this is going to be your cost. The difference is the profit. So revenue minus cost is equal profit, right? And you want that profit to be positive because you want to make money. Once again, this sign stands for greater than. So that's when you make money. So at this point, you might be confused. Well, don't. It's real simple. So at this point, all of these are variables, right? This is a variable. This is another variable. This is also a variable. And this is a variable. So this would be an equation in 4 variables. They're all linear. So you may have heard of linear algebra. That's how you could solve it. However, for the sake of this video, we're going to consider P given. So it's going to be fixed. We're going to consider the cost of scanning given as a given data. And we're going to consider the cost of a pack or a box given. So our unknown is going to be the cost of the chase card. So, long story short, when does it make sense to scan a sealed product? Well, it only makes sense when the cost of the chase card is greater than the cost when this quantity minus this quantity, we're going to go over that, over P plus the cost of scanning. So this right here, this quantity right here, let me create another page. This quantity right here is what? That is your cost. That's the cost of scanning and getting the pack or the box, which we're going to go over that if what happens if you already have the box or the pack and you don't need to buy it. Spoiler, actually, just say now, it's going to be the same because the moment you send the pack, well, you send it because if you find the chase card, you're going to open it. So if you don't open it, then you can still sell it for the market price. So it's going to be the same even if you still have the pack. And right here, basically, everything is derived from this equation of this inequality right here. You solve this, you get this. And I want to make it short and I don't want to go over it. You may, if this is unclear, you need to trust me on that. That's your solution. So when the cost of a chase card is greater than this quantity right here, you're making profit, you're making money on average, right? So at this point, we can go over a few examples. So here we have our spreadsheet. So let's say probability of pulling a, let's use the Greninja from Twilight, right? So the probability of pulling 1 out of a box is approximately 1 out of 850. So that's for a pack. For a box, it's going to be 36 times that over 850, right? That's probability of pulling a Greninja. Now, what is the cost of the box? Is it $120? Let's say $120. Sorry, pack price. So the cost of a box is going to be $120. What is the cost of scanning? Well, let's say the cost of scanning, I heard it's 15. Let's say it's 15, doesn't matter. You can change it. Or you can build this model yourself now that you have a formula. So on average, you're expected to lose $9.50 every time you scan a Twilight Masquerade box, considering this is a probability of pulling a Greninja. This is the price of Greninja. This right here is the price of a box of Twilight. This is the cost of scanning. That's your expected profit. Now, the price of the Greninja, the price the Greninja needs to be in order for you to make money is this one, $128. That's when you make money, considering these variables right here. As simple as that. That's math. It's not me showing you, oh, let's pick base set. Let's pick actually the oxys. No. We picked a set, and I show you a real life example. How did we get to that number? As you can see here, there's a formula. It's a formula I showed you. So at $128.30, you're gonna break even. You don't believe me? Well, let's try it. So let's say the cost chase price, right? So the cost of Greninja is 828.333. And as you can see, we're left with this basically is very close to zero. As a matter of fact, let's use 829. Then we're left basically with zero. So that's break even. So that's just use the mathematical model, the analytical model, and we'll try to give some example. Now, as I said earlier, at this point you're wondering, okay, but what if the cost of scanning is zero? So I heard, well, if the cost of scanning is zero, you are losing money. No. As a matter of fact, most of the times you're making money. And if we go back to our inequality, so our inequality says that your expected value from, let's use this as pack, your expected value from scanning a booster pack is this guy right here, right? And you want this to be greater than this. If this happens, if this inequality is true, then you're making money. That's what we just went over. Now, if the cost of scanning is zero, this is zero, this is zero, this is zero. So you're left CP minus 1T, CC times P is greater than CP. That's what you're left with. Now, at this point, what happens is, if you solve this, so you multiply, you get this. So this is a very simple algebra. Again, if you graduated high school, you should be able to do it, and no matter the country you come from. So you're left this to go away, and you're left with CC. Actually, you're left with P times CC minus CP is greater than zero. So what does that mean? So this inequality is telling you when this is greater than zero, you're making money, and we're assuming that the cost of scanning is zero, so it's free. So if scanning is free, when this inequality is satisfied, then you're making money. Now, this is satisfied basically when the two members here are of the same sign. So either P is negative and this is negative, or they're both positive. That's the only scenario where these two are satisfied. And I'm going to show you right here, when is P negative? So when is the probability of pulling your chase card negative? Never. That's what you use in mathematics to say there's a contradiction. P is negative, and most is equal to zero, but it's never negative. So P is positive when? Always. So at this point you're left, when is CC minus CP positive? And what are these? Let's remember that. CC is the market price of the chase card minus the market price of what? Of the pack. When is that positive? So what that means is, we're saying when is the price of the chase higher than the price of the sealed item? Well, if you remember, the first assumption we made at the beginning of this video was that the price of a chase was higher than the price of a sealed item. Remember that. If you watch the first 1 or 2 minutes of the video, that's the first thing we said. We said it makes scanning, let's say scanning makes sense only when the price of a chase is higher than the price of a sealed item. So when does that, based on our assumption, when is that true? Always. So in conclusion, that's when you make money, when the price of scanning is 0. Only when P is positive and this difference here is positive. When does that happen? Always. So if the price of scanning is 0, you're always making money with our assumption. The only time you're not making money is when the price of a chase is less than the price of the sealed item, which we said if that is the case, we're not going to scan it in the first place. So saying that if the price of scanning is free, you're not making money, no matter, remember, we're not picking a set. This applies to all set, all probabilities, and all sealed items and chase card. This applies to everything. We're just using math, right? We proved it. Let's think about this. When I said CP, did I say CP is the price of base set? Did I ever say that? Or did I prove it for all sets? Did I prove it for all probabilities? And did I prove it for all chase cards? That's how you prove something for everything. If it works for everything, then you can say that you're always making money. So if as long story short, if the price of scanning is 0, when are you making money? Always. So saying the opposite is you came up with a really bad model, or you don't understand what you're talking about. So long story short, that's a simple model. Now, at this point, I'm going to end it because I think this is already 20 or 30 minutes long. And you can make it complex. You can make it more complicated. You can add the probability of that card getting a 10. It's really simple, actually. If you want me to go over that, let me know down in the comments. Let me know if you'll be interested to me of me also making a model for greater cards and CT scanning. And again, last thing is I'm going to show you what we just proved, right? We proved that no matter the probability, no matter the so if the cost of scanning is 0, the cost of scanning is 0, and the only thing that matters is that the price of the chase, this here, is greater than the price of a pack. It doesn't matter the probability. You don't believe me? Well, as you can see here, the price of a chase is greater than the price of a pack. What is your expected profit? 30, so it's positive. You're making money. Let's say the price of the chase price is 200. What's your expected profit? 3. It's positive. You're making money. So as you can see here, the price of a pack. Let's say the price of a pack is 1, and the chase price is 2. What's your expected profit? It's positive. So let's say the pack price is 500 and the chase price is 100. So in this case, the chase price, so the price of your chase card is less than the price of the pack. What's your expected profit? Minus 16. You're losing money. Why is that happening? As we said, even if the cost is 0, the cost of scanning is 0, because this right here is when the price of a chase is less than the price of a pack. Now you said, well, you chose 100 and 500. Well, let's use very close numbers if you don't believe me. Even though this is not a proof, this is just showing you that what I'm saying could be right, but I mathematically show you, considering all sets or probabilities, that I am right. And I know I am because the math is telling you that I'm right. So let's use 499. What's your expected profit? It's negative, so you're losing money. Of 99. So let's get close to 400. What's your expected profit? It's negative. It's very close to 0. This is exponential notation, but it's negative. So again, just because someone sees something, it doesn't mean it's true. Just like I might have made some mistakes, guys. Again, if you find any, please let me know. Even though I checked a couple of times and all the math with all the hypotheses we made is correct. And again, if you want me to go over the PSA price model, let me know. As well, if you have any questions or there's something that I should have considered, let me know. Now let me read the notes one more time. And yeah, I already went over. If you want to consider a box, you just need to use the probability of finding a box, a card within a box, and yeah, and that your expected profit is going to be for the box, not for the pack. But yeah, that's very simple. And yeah, hope you guys appreciate this video. As you know, when it comes to math, I love it because it's my job. So I hope I explained it. I try to explain to the best of my abilities. I understand that if you're, you could be a bit rusty in math, and you don't use it in your daily job. I understand that it could be a bit complicated, but I try to explain it to the best of my abilities. If you want more, let me know in the comments. I would appreciate it if you subscribe and leave a like. Now, again, I'm not cherry picking. This is actually me showing you the math, and this applies to everything. So this is the truth. With the assumption we made, this is actually how CT scanning works when it comes to your expected value of scanning a sealed product. Thank you guys, and I'll see you in the next one. Arrivederci.